Alright, so arrays and eventually vectors. So let's remember what arrays are, first of all. They are a way of holding a ton of stuff, as many things as you need, very quickly. Oh, projector problems. They said they fixed that. Oh man. Okay, so thank you for that. I'm sorry. Let me try reconnecting, and then I'm just going to unplug this computer. Obviously, people don't want us to have class in this room. Exactly. Come on. There we go. Alright, let's see if it stays up. Thank you. And now let me remove the Zoom window because it got weird. Alright, hopefully it's happy. Let's remember what arrays are now. Please yell at me if it ever goes off again. They're just like in one variable, you can put a ton of stuff. Oh no, and now my PowerPoint has given up. Wow, okay. It's one of those days, I guess. Sorry guys, I'll fix this one way or another. There's just too many things open, probably. Zoom and recording and whatever. But it will open eventually. Alright, in theory, it's going to be happy now. Where were we? Okay, let's see if I can draw. Arrays. A single variable where you can put a bunch of stuff. Alright, so I can say something like int r, and I'm worried because that was too small of writing. If I change it, is something going to blow up? Let's see. Yay. Alright, int r, bracket, bracket, equals, and then you can give it a bunch of stuff if you're ready to give it a bunch of stuff. 1, 2, 3. There we go, semicolon. And what that does, right, in memory, it's going to make a place where there are 3 things. I got 3 elements in my array. 1, 2, 3. I have indices 0, 1, and 2 to access those things with or at. Arrays, they come with a size, right? You made this array, it is implicitly size 3. You could have declared it to be something bigger, but you somewhere have to say what the size is, and you can't touch it after that. Like, if you want an index 3, too bad. You should have declared that array with some larger value, right? So you're kind of stuck after you make an array, can't change the size. And similar to strings, though, with an array, you can go into a certain index and change something there. It could be like, go inside of a loop, use like an index I variable. Like, change where I'm at to what it is right now plus 1. Like, increment the value at r of I, cout. You can use that same syntax to, like, get the value as well as set it. Cout, like, r of some j, and have a grand old time. So that's arrays. Hopefully they're coming back to us. Let's do fancier things with them. Let's have multidimensional arrays. You can have any dimension you want, but I'll do 2 because it's easy to draw. You can have 3D arrays if you want. But a good use case for 2-dimensional arrays is like you want to store a picture. You have an image. You have a bunch of pixels in that image. You have rows and columns, right? And it's some rectangle. And so you have a certain number of rows and a certain number of columns. And for each pair, every row-column pair, you're like, all right, store green there, store red there, store blue there, and that's how you make a picture. So you need 2 indices now, one for a row and one for a column. So if you want an array that has multiple indices, we call it a multidimensional array. So you can get like one axis, another axis, something like that. And here's how you declare a multidimensional array. This is a 2D array. It's got 42 things for the first index and 84 things for the second index. So this picture, for example, is a 2x2 array. Let's say that pictures are stored using ints, for example. Let's say that every color is an int. Technically, is a true statement. And this would be how you declare this picture right here with 3 rows and 3 columns. Okay? And so, like, if you want to set this one to 42, you pick, like, hey, is the first thing the rows or is the first thing the columns? I guess it doesn't matter in this case, but let's pretend that the first thing is the rows. So I'll be like R2 of 1, set that to 42, and maybe that's red. Something like that. That's how you use a multidimensional array. It's just like you have two indices, so use both indices now. All right, I hope that makes a little bit of sense. Like go index 2 on this axis, index 1 on this axis, rows and then columns or something. That's how that works. All right, so that is that. A little weird, but hopefully that makes sense. And then once you declare an array like this, 42 in the first one, 84 in the second one, what does that mean your indices are? Like which ones do you have that are accessible? You got R of 0, 0, of course. It's like the first index. And then you can go R, 0, 1. And then on this side, you got 84 of those things. So you can go all the way to R0, 83, right? This is always from 0 to 1 less. And then you can go in the other direction. Oh, shoot, sorry, somebody's calling me. You can go in the other direction. This one has 42 indices, so you can go up to 41, right? 41 would be like the biggest index, 83. So that's how you would use a multidimensional array. A good example would be a picture. Or if you're doing some machine learning, like you store a matrix, you know what that is. Let's just show a little bit of that. Multidimensional. And so, I don't know, let's make a multidimensional array that's 3 by 4. And you can just go into pieces of it. Everything is garbage right now, of course, it's undefined. So if you want to store something, better set it before you use it. R21, set that to 42, and then you can see out it. So that's the syntax. Nothing too fancy. Just on top of what we know. And, of course, we're going to see 42 printed, that's all. So that's that one. Any questions about multidimensional arrays? Not too bad, I hope. Arrays are not the greatest thing in the world. I mean, they're really cool, but they're not like, they don't solve every one of your problems. There are some downsides to an array. I think I've talked about some of these. First downside, you have to like give a size to your array up front. You're like, this array is size 3, no more, no less. Can't change that, which is sad. It also, like arrays by themselves, they don't know what size they are. So like if you do something, you have to like remember in your loop separately, like the array was size 3, it was size 4, something like that. So like here's your array, I don't know, it's got 4 indices, 0 through 3, which you said somehow, like it's of size 4. You don't have index 4, does not exist. Don't you dare try and access it. So all those things. So it doesn't know its size, doesn't know its size 4, and then you can accidentally go here and be like, okay, sure, I'll try, and it might have a runtime error. Okay, so all these things are problems. They don't even save their size. So like you have to store the size somewhere, 42, so that you can remember how high up to go. And so that's arrays. They're good at storing a bunch of stuff, but you have to watch out sometimes. And it has some issues. It can't grow, can't shrink. It just so happens that there's a cooler type called vector that like they made for C++. Arrays is like a C language thing, an older thing. Vectors are built on top of them, and they solve all of these problems actually. So that's a reason to learn them and to prefer them, I think. So before we get there, before we talk about vectors, I want to teach you a very, very important topic, swapping. You can swap variables values, you can swap array indices. A lot of the time, you're going to learn an algorithm, and it's going to be like, let's move this thing in this array to this place over here and like exchange them. So swapping, let's talk about them, all right? Because it's not obvious. So let's say I have this array, and it goes 1, 2, 3. And we have, let's see, 0, 1, and 2 as indices. And let's say I would like to swap the 1 and the 3, so like it's backwards now. So I'd like to move the 3 to here and the 1 to here. It is not as you would expect. You can't do this. This is what you think you might be able to do. Like, all right, place at index 0 the thing at index 2. And then place the thing, place into index 2 the thing at index 0. This is not correct. This won't work. Does anybody see why? this was the array, 1, 2, 3. These two lines do not correctly swap the values. Watch. All right, R of 0 equals R of 2. That means bring whatever's in R of 2 into R of 0. So the 3 is going there. And so this now holds 3. That's what that first line does. And now R of 2 equals R of 0. Bring whatever's in this place into this place. It's just like, it's already 3. We lost the 1. Do you see that? We lost the 1 because we overwrote it. And so the key idea here in bold is that don't overwrite things. Save that thing that you're about to overwrite in a special little temporary variable, and that will work. So here's the secret. Call it like a temp variable. Because R of 0 is about to be clobbered, let's say. Let's store R of 0 in a variable called temp. And then I can do this. Then I can do this for the most part. R of 0 equals R of 2. And now I can set R of 2 not to R of 0 because I just put it there. It's nothing new. It's temp. Put temp into it. And that's that extra place that now holds that thing I might have forgotten otherwise. All right, now let's watch that work. This is the way that works. So here's my R. Indices 0, 1, and 2 holds 1, 2, and 3. All right, int temp equals R of 0. So place whatever's here. Place the 1 into a variable called temp. Cool. Then R of 0 equals R of 2. Boop, that puts the 3 there. And then R of 2, set this place to temps 1, which is perfect. That's exactly what we wanted to do. Okay, so that's going to successfully swap the values. Now the array really is 3, 2, 1. Any questions about that? So that's swapping. Maybe I'll put this in rainbow because it's important. And if you ever want to do this quickly, you can just draw it out. But the pattern is the second thing on the right-hand side of your assignment in the previous line becomes the first thing on the left side of your assignment on the next line. So the zeros correspond. Why is this so small? And then the 2's correspond, and then these wrap back around. The temps are all the same. That's what's left, my guess. That's how I remember it, at least. And that's how you swap stuff. Will be very important for sorting, for example. You're moving stuff around. You're trying to sort an array. Swapping is important there. Okay, we're good with that. Are we ready for vectors? The coolest data type so far. All right, let's learn about them. They are similar to strings in that instead of using these square brackets to go to an index, we are going to instead use .at again. Vectors are strings are C++ types, and so are vectors, and so they agreed on this syntax instead. All right, and so there is definitely a reference page for them. If you go and you search C++ vector on the internet, it will take you here. It's a container type vector. What do we have in the vector type? It's this one. You can click a bunch of things, but these are all the operations that we can do on a vector, just like we could do on a string. Be get its size. Ooh, vectors remember their size. There's our .at. There is some other fun things that I'll talk about. All right, so feel free to stare at this page, but it's a very nice type that we're about to learn. What is vector? It is called a dynamic array. So if you've taken a calculus class, it has nothing really to do with the vector that you learned in math, but I guess you could represent one in a vector, C++ vector type. That works. But it's a dynamic array, which means it can grow, it moves, right? So its size can grow. You can grow a vector with a dot pushback operation, let's say, which is really cool. If you run this, it suddenly adds a new element to the end of your vector, which is like pretending to be an array, and suddenly it just grew. It had an old size, now it has a new size. That's cool. Adds a new element to the back, to the end of the vector. And so if I have a vector, it is just an array essentially. It looks like this again. So if I have 1, 2, 3 stored at indices 0, 1, and 2, I can come along later and be like, I want more. V dot push underscore back, push back a 4 or something. And that will just suddenly make the vector grow. So how cool is that? So now I can put my 4. Now I have an index 3. Now it exists. That's pretty cool. Question, yeah.
So the pushback function, and then increases it by 1 on the end, right?
Yes.
And that 4 is that's the amount, or that's the value stored within that.
Yes, this is the value I want to put in that next element. So if it was 42, I'd put the 42 there. Yeah, it's 9.
So if you want to add several, you would just have to have several pushback functions.
That's correct. Yeah. That's exactly right. There are other ways to add things to vectors, but pushback is the easiest way. Yeah. So also we have this lovely .at. It's really called a method, but I don't want to get into that, so I'll call it a function here for now. So instead of being able to do like v access index 4, and maybe that doesn't exist, right? Instead of doing that, which I guess technically you can do in vectors, but I don't want you to, instead of that, use .at like strings. Do v.at 4 because it will complain and you will get a runtime error if you go to an index that does not exist. That's not guaranteed for arrays, right? So just always use .at and you can never do it wrong. It will tell you when you messed up. So prefer that. Also, vectors know their own size. There's a .size operation. Be like v.size on our current vector in the example right now. That would give back 4 because there's 4 things. You can also give it an initial size, just like you can give an array an initial set of values. You can give it initial elements as well. You can like fill it with like 100 values all holding 42. There's an easy way to do that, which is kind of cool. So yeah, let me show you a few things. Let's have our first demo. Let's have 2 ways to make a vector hold the numbers 1, 2, 3 in that order. That's the easy example. Vectors.cpp. This. So instead of this, int r bracket equals 1, 2, 3, you can totally do this. I have to include the vector library because I want the vector type now. It's a new type. I say vector. It's a little weird. Vector of ints. You read it like that. In between these angle brackets, less than and greater than, you say what type you're storing inside the vector. So it's a little different in syntax, but then you just give it a name. It's like vector of ints, call it v. I want you to hold 1, 2, 3. So almost the same as the array syntax. It's a little bit different. And then this is one way to do it, and it works. You can go into every index and print everything out and be like cout v at 0 and a space, v at 1 and a space, v at 2 and a new line. And that'll print my 1, 2, 3 all on the same line. One, 2, 3, beautiful. We're good with that. It's a vector of ints, we say. It's a vector of ints v, so you can have a vector of strings, a vector of doubles. That's the syntax. Alternatively, you could have made an empty vector. This is something you can't do with arrays. It'd be like vector of int v2 semicolon. Crazy. So this makes v2, starts it out as an empty vector. That's a normal thing to do with vectors, actually. Start out empty, because you can add to it. It is an empty vector of ints. All right, and then I can push back to it. v2 dot push back the 1, then the 2, oops, then the 2, then the 3. And now it also holds 1, 2, 3 in that order, because I added 1, 2, 3 to the end in that order. So let's print out. It's all 1, 2, 3.
So an empty vector has like 0?
0 size, yeah, 0 elements.
No. If you wanted to get that, that'll return 0?
Yep. You can say dot size v, you can print out the size. Oops. You can ask it for its size. Cout v2 dot size. It knows how big it is, and at the beginning it is really 0. Yeah. So it's 3 now, but it used to be, if I put it there for a second. Zero. Crazy. Yeah. Any other questions? All right. So, fancier example. Let's get infinity elements from the user, so we can have a vector grow. We don't have to have the user like know how much they want. We can just keep asking the user, hey, do you want to put more stuff into this vector? Because I can make it grow for you. All right. And then we'll just keep on getting numbers until they type -1, and then maybe we'll, should we print out the vector? That's probably the easiest thing to do. after we've built it up. So let's get as many elements as the user wants to type. So I'm going to make an empty vector of ints, v3, and then, just forever, while true, ask the user for something. Enter a number to add to v3, and then they can type -1 if they're done. All right, let's have -1 be the stopping point. And let's get n, and then if that number we just got from the user is -1, break to stop this infinite loop. Otherwise, if we're still here and it wasn't -1, then add it to v3. v3.pushback that n that we just got from the user. And so this loop is going to continue as long as the user wants to type stuff. And we're just going to keep on adding the next thing to v3 until they type -1. Then we're done, and we have a giant vector, potentially, right? Then we would like to go through the entire thing. It's going to work right now. I haven't really told you how to go through a vector yet, but I think you can get the idea. But it's working so far. 5, 6, 7, 8, and then -1. So now it's a vector of size 4 inside it. 4 things got placed into v3. All right. So we still need to loop through v3 or do something with the values, but that's how you get them. Does that part make sense? Okay. Then let's talk about iterating. Right? You can do it the old way because you know its size. You'd be like 4 int I equals 0, I is less than v dot size, I plus plus. That makes sense. That works. Let me show that to you. Let's iterate through v3 and visit every index. I'll just print them out all on the same line. Why not? So for int I equals 0, and it's v3 I'm going through. So this vector right here, v3. So for int I equals 0, I is less than, what's the biggest index? Well, I want to go up to the size of v3 minus 1, so I can just be like I is less than v3 dot size. It knows its size always. I plus plus. And then, all right, inside the body here, inside the body here, I could be like cout v3 at I, so whatever index I'm currently at. Go there, look at it, print it out. So here's me using the vector that I just built up, getting those things from the user. 5, 6, 7, 8, size 4, and so it's going to print them all out, and it's of course different every time. It's 5, 6, 7, 8, 9 this time, -1. It'll add as many things as we want to add to it, and that's how you go through it and print stuff out. That's the way that looks like the array iteration way. Good with that? Alright, there's a cooler way. If you just want to go through a vector in order, there is a C++ version 2011 and later cool new thing. It's default now, which is nice. It's called a range-based for loop. It only works for vectors. This does not work for arrays because arrays are old and not part really of the C++ language. Vectors are though. So you can do this. You can say for, and then it looks a little weird. You're going to say int, if the int is what's stored inside the vector. If it's a bunch of ints, you can be like for int elem in your vector v, do something with this elem variable. And so what this is doing is if you have a vector called v that holds ints, I don't know, 1, 2, and 3 again. This range-based for loop is going to work like this. It's going to be like for every element in v, you read the colon as the word in. For every element in v, what's going to happen in the body is it's going to make this variable called elem, and it's just going to go through the vector for you, having elem set to each value one at a time. So every time you hit the body, you have a new value stored in this elem variable. That is the next thing that we need to look at. So you can like work with that variable, cout elem or something, in a space, like we were doing. So elem gets a chance at being every value, every index in this array from left to right. So the very first time we hit the body, elem is set to 1. Then you run the body again with elem set to 2, because that's the next thing in the vector. And then it'll get run with elem set to 3, and then that'll be it. So for every int element in v, for every element in v, call it elem, work with it. That's how you read that. It's kind of cool. It just goes through the whole vector from left to right. It's called a range-based for loop. So you're going through the entire range of that vector. So let me show that to you. Hopefully it's going to make some sense when I do. We have, I'll call this iteration.cpp. Oh, weird. Don't know what happened there. I need vectors, so I want to include the vector library, of course. And then let's make a vector of doubles this time. Vector of doubles. Call it v, set that to like stuff that have decimal places. 1.5, 2.75, 3.14. So there's a vector, and let's iterate through it the normal way. Let's be like, all right, for int I equals 0, I is less than, well, once I need to go to, I needs to be less than 3, right? But what is 3 but v dot size right now? Isn't that beautiful? V dot size, I plus plus. So we got all that. And then, let's see here. Now I is ranging over all the indices in V. I don't know, let's just print it out. That's the easiest thing I know how to do. C out V at I, so wherever we are right now, this is the old way, the old normal loop way. And then, I don't know, new line at the end to break that last line. This will go through everybody, as usual. I'll call this iteration.cpp. Iteration. Alright, so we're going through it. Now, instead of this, we can use the range-based for loop. So, it's not going to be for int element v. This is just a variable name, by the way. You can call it whatever you want. Int x, int y, whatever. But it's going to be double element, right? Because that's the type of thing stored in this vector now. It's a vector of doubles, not ints. Range-based for loop. So I can say for double element in v. So go through v, have element have a chance at being everybody from left to right. And so every time we hit the body, element is set to the next value of the vector that we haven't seen yet. So these two things are more or less equivalent. So that's that. Whee! And they're going to do the same thing. So from left to right, 1.5, 2.75, 3.14. Any questions about that? So that's how you read it. For every element in V, call it elem. Work with it. This is for every valid index in V, do something at that index. How you think about those things? Any questions about either of those? Make enough sense? Those vectors, they can grow. They're very cool. Is there anything else I want to say here? Yeah, usually you want to go through a vector from left to right, so like the range-based for loop is less typing, makes more sense. But sometimes you want to like iterate in a weird way through a vector, and then you're kind of forced to use indices. Like if you want to go in reverse, you want to go every even index or something, it's easier to maybe use indices to do that. Okay, so there are reasons to prefer either one. They're good at different things. So let's see here. Yeah, if we're happy with that, let's keep on trucking. Let's talk about sorting. So, all right, if you have a vector, chances are you would like to probably have the elements in order sometimes, like you want to like show them to the user in a pretty way. And so there is a sort function that we can just use. It's made for us. It lives in the standard library. It's in the algorithm header because sorting is an algorithm, right? So if we go and look at that, I think it's in other. Oops. Yeah, we have the algorithm library. Now there's a bunch of cool things I encourage you to look at. That some are very difficult to use though. Sort is not doesn't make any sense until I explain it anyway. So these aren't the easiest to understand or the easiest to call, but some of them are normal things that you'd want to do. So let's talk about sort. That's a function in this library, and you can call it in two ways. You'll be like, you can give it this thing, and give it a first and a last, or you can give it a first, a last, a compare. We're going to do it this first way, and I need to tell you what a random access iterator is, which is a little disgusting. A I think what I want to say is just ignore those words. I'll show you how to call sort on an array and on a vector. All right. So, but what it's going to do is it's going to sort the elements. You give it a range. You like sort from here to here, please, in the vector, because you can like sort the first half of the array only if you want to. The first half of the vector if you want to. That's fine. And so you're going to give two things. Sort takes two arguments, first and last, and it's going to sort them in ascending order. And it's going to sort from first inclusive to last exclusive. All right. So have we seen this style of like ranges before? So first is inclusive, so it's taking that index, and then it's like going up until, but not including the last thing. Right. So like we're trying to sort from start to end. Let's go on like this, right? So you give, if you want to sort an array, for example, or a vector, you're going to give it the start and the end of where you want to sort, kind of in memory. That's how you think about it. So you're going to say sort, please sort my array from the starting place in memory where it lives to the ending place in memory where it lives, but really, because it's going to sort from start inclusive to end exclusive, really, you want to give like the memory address of like one past the end, so it includes your real end if you want to sort everything. So call it with your start place in memory, and then also what I will put in quotes, one past the end. Which is a weird thing to think about. Don't worry too much. This is just one of those things that you kind of have to memorize right now, and then it will make a lot of sense later, much later in the class once I talk about pointers. So this is how you call sort. You give it the starting place in memory of the thing you want to sort, and then one past the end of where you want to sort, so that it includes the real end. That's how you do it. And then here's how you call it. All right. Vectors know where they begin and end in memory. They have methods. They have operations for those things. So if you want to sort a vector, you just say sort, and then you give it v.begin and v.end. That is technically, this becomes the start of the vector in memory. This becomes one past the end of the vector in memory. And then to sort an array, you call it in a very weird way. You say the name of the array, sort R, just like that is apparently the start of it in memory. And then you say the one past the end is the name of the array plus its size. So you do arithmetic on the name of the array, which makes sense to me because I know the secret, but it's probably very confusing to you, and I will tell you the secret later. I promise. But for now, this is how you sort things, all right? I can talk to you after class if you want to really know right now. But here's how you do it. Let me just give you a file because you're going to want to sort stuff. Let me show you how to sort a vector and how to sort an array. All right, so sorting.cpp. All right, so if let's make an array, int r equals, 8, 6, 7, 5, 3, 5, 9. So I have a jumbled array, and let's do the same for a vector. So let's include the vector library for that. So I'm going to make a vector of ints, call it v. So I have both of these, an array and a vector. If you would like to sort the array, if I want to sort anything, I need to include the sort function in the algorithm library. Algorithm for the sort function. And so now, if you would like to sort things, for the array you say sort, and then you give the starting place to sort in memory, which is just the name of the array itself. That translates to its starting place in memory. And then you give one past the end in memory where this array is, because I want to include the 9 element. Go everywhere. So I'm going to say r plus its size. It's very weird. You can do math on the name of an array. So how big is this? It is 7 long, so I'm going to say r plus 7. And that is how you sort an array using the sort function. Very weird. For a vector, it kind of makes more sense because they made a nice little helper operations for this. If I want to sort a vector, you give the beginning and one past the end in memory of the vector. So v.begin and then v.end. Those exist in the vector library. It's all lovely. Where were we? It knows where it starts and ends. Like beginning, end. It knows. Question? Yes.
When you're typing an array in the sort,
Yes.
can you notice replace
This number here is 0. And then make it just like from 0 to 7 or something. That would make sense if, because it has no clue what to sort right now. You'd have to like give the array in a separate parameter because it's like, I don't know what I'm sorting. Do you want to sort this array? Do you want to sort this other array over here? Pretty much, yeah. This is saying, this really does translate to the starting place in memory of that array. I promise. It's not going to make sense until we talk about that, which is, we need a lot more stuff first. It's going to be well after the midterm. But yeah, that's a very good thought. This really does translate to memory places. Yeah, it's a little weird though. But it's also how we tell it where to sort. We want this array sorted, please. So that's the syntax. And then suddenly, just miraculously, these things have been sorted. We can iterate through them and print them out, and now it's suddenly in sorted order. So 4, int I equals 0, I is less than 7, because arrays don't know their size. We have to remember it for them. I plus plus, cout rvi, and maybe a space. A new line. So that's how we print the first one, and then, well, we got a vector. We might as well use the range-based for loop. It's faster. So for every int, call it e and v. Look how fast that is to type. Cout e, and a space. And a new line. Alright, so here's the relevant code. Making an array, making a vector, sorting them. Let's just memorize this for now, unfortunately. I will explain it to you right now if you'd like to. But we can do that offline. Sorting, /sorting. And voila, we have sorted things. Alright, so it's a little weird, but hopefully it makes at least a little bit of sense. Are there any questions about that? Because yeah, sorting is an algorithm. It's like, you want to do this, I want to somehow take these, I don't know what order they're in originally, I want to make them ordered. That's an algorithm. I want you to now come up with an algorithm for something else. You don't have to write this down anywhere, but get with your neighbors, please say hello, and maybe take out a piece of paper because you're going to want to draw some stuff, all right? Pretend we have a vector, all right? Here's the setup. Pretend we have a vector of some size, and the vector is not necessarily like in order or anything. It's like jumbled. I have a vector. It looks like this, maybe like it's 1, 4, 3, 2. I don't know. It has those indices. With your group, please come up with an algorithm, see if you can, to reverse this vector. I would like to take v and change it so that after your code is done, after your algorithm has run, v now looks like whatever it was in reverse order. So 2, 3, 4, 1 at those indices. So that's the same v though. We're messing with stuff. What was this becomes this. Now it's backwards. See, going through that way. Does that make sense? That's what we want. See if you can come up with an algorithm to reverse the contents of a vector. And it should work no matter the size, right? If it's an odd sized thing, it should still work. Doesn't matter. Size 1 should still work. Size 0 maybe. Don't have to do anything. So there might need to be some statements involved, I'm not sure. But just on paper, see if you can draw like what needs to happen. You can use v.size to get like how far you need to go through the vector, right? So you have that at your disposal. You can use the .at to get at single indices as well. But how would you reverse the contents of a vector? See if you can come up with a good idea. You don't have to write this down anywhere. Just as a group, come up with an algorithm. This is good knowledge for your brains. So I'll give you several minutes to think about this. And I'll show you my way. It's the same vector. You're updating that same vector with the original values reversed. Take like 3 minutes to think about this. Draw pictures. You can write code if you want to, if you have time. All right, take 30 more seconds to think hard, and then I'll show you what I'm thinking. Right. I want to hear your stuff too. Okay, so I think I'm done writing code for the day. We're just going to talk about it in words. What were our thoughts? What do we think? What was a good idea? Can anybody explain to me their idea in words? You're brave. Like I have this vector. It's 1, 4, 3, 2. What are you going to do to make it 2, 3, 4, 1? Oh, nice. Can you describe the ugliness to me? Okay, sure. I see. Yeah, so you're filling up another vector. That makes sense. Yeah, so you're like going to iterate in reverse through this vector and build up a new one. Yeah. And then maybe place this all back into here in one other iteration. Something like that. Yeah, I like that. Any other ideas? So that makes a lot of sense to me. Whee. Does anybody think of a way that doesn't involve making a second vector? Ooh. The secret involves something that we talked about a little while ago. Look at how there's like kind of like a mirror that you want to do here. I want to take this 2, put it here. I also want to take the 1 and put it here. I want to swap them. See that? I want to swap them around the midpoint. Make this a 2, make this a 1, make this a 3, make this a 4. So I want to swap them and then like stop once you hit the middle. That's the algorithm that I want to tell you about because it's a little fancy. It's kind of cool. You don't have to make a new vector or anything. You're just going to like iterate up until the middle, right? But it has to work for arbitrary sized vectors. So if it gets a little weird looking when you have a vector that is odd sized. Oh, question first. Yeah. That's right. Let me go back to that slide just to refresh our memory. It's this idea. If I want to exchange 2 values in an array, or just 2 variables, I want to save one somewhere for a split second. And so if I do a bunch of swaps, that's one way to solve this problem. It's one way to reverse the vector. So I have this one. This one gets a little weird because there is no, like I want to translate this into 3, 5, 7, 6, 8. And so I still want to swap like this one and this one, this one and this one. And then there's a concept of like, this is the middle. Do I swap it with itself? Like, how does that work? So it does get a little weird. Maybe you just want to stop there. Honestly, you just want to stop there. The 7 doesn't move. So that's the idea. Yeah, let me show this to you. We'll come up with code next time. Let's discover what we need to write and make it work. So reversing the contents of a vector or an array. We'll implement this algorithm next time, but we're going to come up with a good plan for it right now. All right. That's got to work on any vectors. Like here's my vector v. Not necessarily in order, but for this example, let's make it be in order. 1, 2, 3, 4. 0, 1, 2, 3. And so, all right, let's notice what we need to do. So if I have this vector, for example, like I notice here's the midpoint. What exactly is involved here? Like I want to swap these guys and these guys. What does that mean? How do I translate that into working for an arbitrary sized vector? Because it should work for v0, it should work for v, and it should also work for like a second v that has 5 elements this time. So like here's this one. What I'm about to write should do the same thing for this code. Like this is 1, 2, 3, 4, 5. How can I write a line that both swaps this one and this one if it's v, and this one and this one if it's v2? And so what do we need to swap? We need to swap. Now I have to get tricky with the indices, yeah? I want to always swap, no matter where I am. It's always the 0th thing. It's always the first thing I see. With the last thing. How can I calculate the last thing, no matter the size of the vector? Remember? There you go. So it's v.size minus 1. So I would like to swap the very first round. Swap indices 0 and v.size, assuming they're all called v, v.size minus 1. That will always get me my last index, no matter where it is. No matter how, like if it's a size 1 million, it'll get me index 999,999. So that's the first thing I want to swap. And then I kind of want to bring it inwards. So then I swap in the next index with the second from last, right? The next index with the second from last index. So that's swap indices 1 and then v.size minus 2. So you're working your way in from the other end. You see that? v dot size minus 2. Does that make some sense? And then you're going to do that as much as you need to. And now the question is, how many times do I do the swapping? Because after this many times, what has happened? What has happened to v, for example? So it held 1, 2, 3, 4 at indices 0, 1, 2, 3. If I run these two lines, right, swap 0 and v dot size minus 1, that's going to be 4, then 1. And if I run this one, I'm going to swap indices 1 and v dot size minus 2. That's going to be the 3 and the 2. And then I'm done, right? So actually, I only needed 2 swappings to finish this. Actually, if you keep going, it's gonna put it right back in order. So if you do it the other way, if you thought that you wanted to swap 4 times, if you mistakenly thought that, you'd end up being like, all right, swap indices 2 and v dot size minus 3. That would swap indices, all right, 2 and v dot size is 4 minus 3 is 1. It would swap 2 and 1 again. So now it's back to 2 and 3. And then if you kept going, 3 and v dot size minus 4. Size is 4, so it's swapping indices 3 and 0. And so now it's back to normal, 1 and 4. So you only want to go half. You only want to go half. Does that make sense? That's how that works. So how many swaps do I want to do here? If it's size 4, I want to do 2 swaps. Okay? And then, if it's this size, I also only want to do 2 swaps. You see that? Like this one, I don't have to swap 3 with 3. That's silly. I still only want to do 3 swaps. Just like, don't even let this one happen. So again, if it's size 5, I want to do 2 swaps. And so if you think about this with enough, if you give it enough thought, try a bunch of examples, you'll notice you can just divide by 2. 4 divided by 2, that's how many swaps I need to do. 2 swaps total for this one. This is size 5. 5 divided by 2, integer division equals 2. That's also how many swaps I want to do. Because the middle doesn't count. The middle stays where it is. All right? So no matter the size of the vector, we always want to do size over 2 swaps in this order. And that is our algorithm. You're doing integer division, by the way. You can't do half a swap. That makes no sense. Always size over 2 integer division swaps. And that will correctly reverse your vector. And it's doing it in place, we say, because it's not making a second vector to move things into later. We're working on that original vector, just swapping elements of it. Okay? So that's the idea. Any questions about that algorithm? See how it might, you might write a loop that does this, like you got an I variable increasing. You know how many times to run the body of that loop. You can usually calculate this using your I variable. We'll talk about that next time, but do you see it kind of coming together? So that's where we're going to go. But I would like to just have this turn in your brain for a while before I implement it. So we're going to do it next time. All right? And I think that is all that I wanted to talk about today. Let's see, anything to release now? Okay, yeah, so that is everything for the day. Please do attendance if you did not. I will stop that in just a second if you forgot. And yeah, the rest of the time is yours to work and to ask questions.